Wake up, fourth graders. It's time for another math lesson. Now, this is going to feel a lot like yesterday, except the units are slightly different. Today, we are talking about something called volume. Volume is not distance, it's not mass, it's how much space is taken up by an object or a fluid. Um, you would actually learn more about it in science. In fact, you may even get a bit of that this year. I'm not quite certain. Anyway, so volumetrics, the conversion ratios are a lot like what you've seen before. So I think it's going to be fine. So just relax, strap yourself in, and off we go. So you have 1 liter. Well, you've seen 1 liter before. Actually, you've seen it times two. Those big honking bottles of soda. Those are 2 liter bottles. Yeah, that's a lot of soda, man. Anyway, 1 liter is expressed as one with a big capital L next to it. That's how we abbreviate liter. How many milliliters are in 1 liter? Whoa, whoa, whoa. Wait, Mr. C, you've introduced new vocabulary. I know, right? The milli. Well, this is going to be a little bit of Mr. C, you told me already that kilo means 1,000. Guess what else means 1,000? Milli. It's true. I have confirmation. 1 milliliter is about one eyedropper full. Wow, that's not much. So think about that. Relate that back to half of that bottle of soda, okay? So 1 liter, it takes 1,000 milliliter drops to make a liter. Now, frankly, I don't think you should verify this because it will take you quite a long time. So just take my word for it. It'll be fine. It's a well-established fact in the metric system. So here's where we begin. 1 liter is the same as 1,000 milliliters. My phone's laughing at me again. Anyway, back to the math at hand. Surprise face. That's not a very good surprise face, but I think you get the idea. Anyway, so what do you do with that? Well, I have an example for you, a real world example. There's something that you would have used it and you actually may see it in some of your, in maybe one of your science videos this year, but you'll definitely use it at some point in middle school and high school, probably chemistry or biology class. Anyway, how do you use a graduated cylinder? Well, what does graduated mean? Graduated means it has little divisions on it. It's a graduated container, and it just so happens that the most efficient way to do this is something called a cylinder. Cylinder looks something like that. Yes, I drew that myself. I'm so proud. Now, let's say you put a certain amount of water in that, and yes, water kind of has this really cool thing. I learned this back in middle school, so this is kind of a callback to that, where if you look at it from the side, it's really cool. There's not a straight line. It's kind of like there's this dip because the molecules of the water actually hang on to the inside of the cylinder. I know, blah, 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 Mr. C. Anyway, you will want to line things up with the bottom of that little, like, it looks like a half bubble. Anyway, so here is an example. I'm going to pour 1,000 milliliters into a graduated cylinder. I'm going to add another 500 milliliters more. So think about that. What's my total number of milliliters so far? Go ahead and have that number in your head. Add another 500 milliliters. Okay, this isn't funny anymore, Mr. C. How much is that? Really? Well, let's see. 100 plus 500 plus 500. I'm going to take the two 500s, add those up to make 1,000, and add that to the first 1,000. So my number is 2,000. What's yours? 2,000 milliliters is the same as 2 liters. That was just to make my point. It's kind of like yesterday and the day before that. In other words, the conversion ratios to this point, no pun intended, have been mostly 1,000 to 1. Yes, there was centimeters, but we're not going to talk about centimeters right now because that will just confuse you. But yesterday and today is all about the 1,000 to 1 ratio. And what you'll find is it breaks out the same as the calculations you did today. So for example, if I have 32 liters, and I'm going to add that to 13 liters and 585 milliliters, I'm not sure I said that right. 32 liters, 420 milliliters plus 13 liters, 585 milliliters. I would set it up vertically like that, even if it's written from left to right. And then just go ahead and do your adding. Now, this is the crucial part right here. Watch what happens. I have 45 liters, no problem, no big deal. But notice the number of milliliters I have. Well, that's more than 1,000 milliliters. What's that mean? That I have a liter that's hiding in there. I guess I'm saying that just to kind of up the suspense. The fact is, it's not hiding. It's already there. You know it's there because 1,000 milliliters is equal to 1 liter. So what you do then is okay, we've circumvented this. So what happened here is I've got, in fact, I'm going to back this up. This video was made quite a while ago, and I thought that I had this dialed in, but what must have happened is this must have been erased. Anyway, so what's going to happen here is, in fact, I'm going to go ahead and delete those two. I know that 1,000 milliliters is the same as 1,005 milliliters is the same as 1,000 plus 5, right? And I know that that's equal to 1 liter. Yes, this is how Mr. C shows his work. So I'm going to put a stop in there, and notice that I'm going to end up with I'm going to take that other liter, I'm going to add it to the existing 45 to make 46 liters and 5 milliliters. Remember, I've got 5 milliliters here that has nowhere to go. Oops, better circle than that, Mr. C. So this is, I'm going to say, except for the units, which are now liters and milliliters, this is exactly like yesterday's work. So don't overthink this. It's the same kind of process. If nothing else, it gives you a chance to practice your skills in making the conversions. I will maybe give you some tips on how to simplify your work in the homework set, but you're on your way. I think you can do this, and I'm going to give you one more example to kind of prove that point. So I have 12 liters and 215 milliliters. Oh man, this is wrong. So I'm going to add to this. So I'm going to add, yes, Mr. C is making things up on the fly. Let's go with, oops, that's a bad pen color. Let's go with black again. And let's say, I'm going to say 13 liters and 875 milliliters. Okay. And if I add those two, again, I'm going to get, I know my units here are going to be milliliters, and I'm going to get 10 and 9 and 10. I'm going to give that a little bit of a scooch over to the right. And then I know that I have, oops, and that was supposed to be an addition symbol. I'm going to back that up. And there we go. And I've got 25 liters and 1,090 milliliters. I know that this converts to 1 liter and 90 milliliters. You like how I did that fancy little switch of pen colors? So do I. Oops, sorry about that. Oops. So 25 plus, oops, 25 liters plus 1 liter. So in total, I end up with 26 liters, 90 milliliters. So you may have already stopped watching because you thought, okay, Mr. C, I get this. I'm going to go on to the homework, and that would be fine. Anyway, this is just like yesterday. The only difference here is now we are measuring volume. And I'm going to just go out on a limb here and say this is really, we're relating this to a liquid volume. Yes, if you were to put some kind of a solid inside a container of some kind, it would work the same way. But thinking of this in terms of fluid just makes it that much easier as far as I'm concerned. Anyway, if you have questions, please ask, but I have a feeling this is going to be kind of a slam dunk. So if you did well yesterday, just rinse and repeat. That's today. Talk to you soon if we need it.